Have you ever wondered how a program seems to, well, think? How it responds differently depending on what's happening? Well, that's all about making decisions in your code. And today, we're going to pull back the curtain and show you exactly how to do it in Python. All right, let's get into it. So here's the big question, right? How does a piece of software, which is really just a list of instructions, actually make a choice? How does it decide to do this thing instead of that thing? It feels like it should be complicated, but the answer is actually super simple. And believe it or not, that's it. The entire foundation of decision-making in pretty much all of programming starts with that one little word, if. It's basically how we ask our code a simple true or false question, and the answer decides everything that happens next. Okay, let's start with the most basic building block. This is where you tell your program, hey, I need you to check if this one thing is true. And if it is, and only if it is, I want you to run this specific piece of code. The best way to think about it is like a gatekeeper. Your if statement is standing guard in front of some code. It looks at a condition, basically a question, and if the answer is true, boom, it opens the gate and lets the program run that code. But if the answer is false, that gate stays shut and the program just walks right on by, skipping that part completely. Now let's look at how this actually works in Python. It's really clean and easy to read, right? We've got our keyword if, and right after it is our condition, age greater than or equal to 18. That's the question we're asking. Then you see that colon at the end? That's super important. It tells Python, okay, the question is over, what comes next is the code to run. And notice how the print line is indented. That's how Python knows that this specific line belongs inside that if statement. And here's the result. If we told our program that the age was, let's say, 25, then the condition 25 greater than or equal to 18 is obviously true. The gatekeeper opens the gate and our print function runs, showing us that success message. Simple as that. But wait a minute. What happens when the condition is false? What if our age was 15? Right now, our program just does nothing. It just skips the code and ends, which isn't very helpful. We need a backup plan, right? An alternative path for when the if condition isn't true. And that backup plan is called else. It's literally the otherwise in your code's logic. You can just read it out loud. If this first thing is true, do this. Otherwise, do this other thing instead. It's the default action when your if check fails. So let's see how this builds onto our code. See, we've just tacked on the else keyword, and just like if, it has a colon and its own indented block of code. Now our program has two possible outcomes. It's always going to execute one of these two print statements, but it will never run both. So if we run this new version and say the age is 15, the first condition, 15 greater than or equal to 18, is false. The program completely skips that first print statement and jumps directly down to the else block, running its code instead. Now we're giving the user helpful feedback no matter what. Okay, so if and else is great for two options, a simple yes or no. But let's be real, life is way more complicated than that. What if we need to check for 3 or 4 or even more possibilities? I mean, do we just stack a bunch of if statements? You could, but there's a much cleaner way. And that's where elif comes in. It's just Python's cool shorthand for else if. What it does is let you chain a bunch of different checks together. So why is this so useful? It keeps your code from becoming a tangled mess. Instead of nesting ifs inside of ifs, elif creates this clean, logical ladder. The program checks the if first. False? Okay. Move to the first elif. That's false too. Okay. Move to the next elif. And so on, until it either finds one that's true or runs out of options and hits the final else. All right, let's put it all together and check out this much smarter version of our code. Let's trace the logic, step by step. First, the program asks if age greater than or equal to 100. We check our most specific case first. If that's false, and only if it's false, it moves down to the next rung on the ladder, if age greater than or equal to 18. If that also fails, it keeps going to if age less than 0, which is a clever way to catch bad data. And finally, if none of those other conditions were met, our program lands on the else block as a catch-all for anyone who's under 18. And this brings up an absolutely crucial point. The order of your if and elif checks is everything. Look at the bad example on the left. If a user says their age is 102, what happens? The very first condition, age greater than 18, is true. The program would print, "You are now signed up," and just stop. It would never even get to the age greater than 100 check. That's why on the right, we put the most specific check first. So far, we've only been playing around with numbers, but the power of if statements goes way beyond that. You can use them to make decisions based on text or even simple true or false values, which are called booleans.
But before we do that, listen up, because this one little detail trips up almost every single person when they're starting out. A single equal sign means a sign. It's for putting a value into a variable. A double equal sign means compare. It's for asking the question, are these two things equal? If you mix these up, your code won't work. So always remember, two equal signs to compare.
Okay, now check this out. We can ask a user a question and then check their typed response. Here, our if statement is using that double equal sign we just talked about to see if the response variable is exactly equal to the letter Y. If it is, great, we offer them some food. And this is a really slick shortcut. A variable that can only be true or false is called a Boolean. Since an if statement is just looking for a true or false answer anyway, you can use a Boolean variable directly. Just writing if online is the exact same thing as writing if online equals true. It's cleaner, it's faster to type, and it's what you'll see all the time in professional Python code.
All right, you've just learned the fundamental logic that makes pretty much the entire digital world go round. Seriously. So let's just do a quick recap of the flow to make sure it really sinks in.
It's really just a waterfall of logic. The program starts at the very top with the if. The very first condition that it finds that's true gets its code executed, and then the whole block's finished. It doesn't check anything else. But if it goes all the way down the ladder and none of the if or elifs are true, then that final else block acts as the default, the final catch-all. So that's it. That's the foundation of decision-making in Python. You now have the power to create programs that aren't just a boring list of instructions, but they can actually react, adapt, and respond intelligently to different situations. The only question left is, what are you going to build with it?